Hello student, in the lectures of haloalkane, haloarenes, today we will discuss reaction of haloarenes. Okay, dear student, as like haloalkane, you know that in haloalkanes SN reaction is possible. SN means nucleophilic substitution. The reaction is possible for haloalkane or alkyl halides. Dear student, but let us remember that for haloarenes nucleophilic substitution reaction is not possible. It possible only in drastic condition. The question is why? Why haloarenes does not occurs SN reaction, means nucleophilic substitution reaction. Dear student, here arene halides, that is haloarenes, like here, are less reactive towards the SN reaction. The reason is due to, the first reason is due to resonance effect. Dear student, you observe here in arene halides like chlorobenzene, the electron present on the chlorine, the lone pair present on chlorine, are dragged towards the benzene ring due to high electronegativity of electrons present in benzene ring. The carbon present in benzene ring are dragged the electrons of chlorine towards the ring, and therefore when electrons come to this carbon here formed multiple bonds, and electron density increase. Due to increased electron density, the pi electrons move to the next carbon, like here, and next carbon occurs positive charge and chlorine occurs negative charge. Dear students, again here this electron pair from these carbons move towards the next carbon, and due to increased density of electron, the pi electrons move the other carbons and form here negative charge here pi bond. Again the electrons rotate to next carbon, and due to increased electron density here, this pi electrons move the next carbon. Dear student, you observe here in all the example first resonance, these are the resonance structure. In resonance first, resonance second and resonance third, you observe here chlorine acquire multiple bond, double bond. Dear student, in haloarenes CCl bond acquire, like here CCl bond, CCl bond acquire partially double bond character. Here you observe here double bond character and double bond character. Due to acquire double bond character between CCl, yes student, CCl bond acquire a partial double bond character. Due to double bond character, resonance. Due to resonance, this double bond character due to resonance. Dear student, when benzene ring attached to the halogen, the electrons of halogens move towards the benzene ring. This is the resonance, and due to resonance, carbons and chlorine acquire partial double bond, and due to this partially double bond characters, as a result, the bond cleavage in haloarenes, is difficult than haloalkanes, therefore less reactive towards SN reaction. Dear student, you know that in SN reaction, in alkyl halide, the halides act as a living group. It leaves from to the carbon. But this is the SN reaction. But the leaving of halogen from the carbons of haloarenes is not possible. It is because due to double bond characters. This double bond characters acquired due to resonance. Dear student, always remember, due to resonance in haloarenes, the partial double bond character between carbon hydrogens present, and this is the reason that haloarenes are less reactive towards acid reaction as compared to haloalkane. Okay. Dear student, now discuss second reason. Dear student, the second reason is difference in hybridization of carbon atom in CH bond. Dear student, if you observe here, this is arene, haloarenes, and this is haloalkanes. Haloarenes and haloalkanes. Dear student, in haloarenes, the hydrogen attached with this carbon, and this carbon have the 1, 2 and 3 sigma bond. If carbon have 3 sigma bond means sp2 hybridization. This means in haloarenes the carbon which joined with halogen have the sp2 hybridization. Yes students, but in haloalkane the carbon which is attached with the halogen have 1, 2, 3, 4 sigma bond. 4 sigma bond means sp3 hybridization. Dear students, sp2 hybridization and sp3 hybridization. Yes, in sp2 33.3% yes character, but in sp3 hybridization yes character is 25%. Okay. Dear student, as increase S characters, the electronegativity also increase. Okay. So here in haloarenes acquire sp2 hybridization and haloalkane acquire sp3 hybridization. It means the carbons of halogen, the carbon which is attached with the halogen is more electronegative as compared to carbon of haloalkanes due to sp2 hybridization. Dear student, because here in haloarenes the carbon have more S character and high electronegativity. Dear students, sp2 carbons with the greater S characters means more electronegative. Dear student, can hold electron pair of CH bond more tightly. Dear students, they do not leave the carbons, the sp2 carbons in benzene ring do not leave the halogen due to their high electronegativity. It hold the halogen with them. Okay, and due to this, when halogens not leave, Sn is not possible. Okay, the second reason is, and now discuss third reason why haloarenes is less reactive towards the Sn reaction. The third reason is instability of phenyl cations. Just when you know that if haloarenes lose their halogen, when halogens leave, it acquire positive charge. This is the phenyl cations. But you know that due to high electronegativity of this carbon, due to resonance of the benzene ring, it is not possible to leave the halogen. So we say that it is not possible to form phenylcations. And if cation is formed, this is not stable by resonance. So we say that in haloarine SN1 reaction is not possible. Okay. The fourth reason, repulsion between the nucleophile means electron rich species, and arenes also electron rich. Dear student, you know that haloarenes have the 3 pi electrons. In haloarenes have 3 pi electrons. It means haloarenes is electron rich species. And you know that a nucleophile have the lone pairs minus charge. So we say that lone pair also electron rich species. When 2 electron rich species come closer to each other, then repulsions created. So we say that nucleophile will not approach closely for attack due to the repulsion. Dear student, if chlorines leave from their site, if in some region chlorines leave, but it is not possible to attack of nucleophile. You know that when leaving group leave, then nucleophile attack. Dear student, here when halogens leave and the carbons of haloalkanes became the deficient, so easy to attack of nucleophile because it is electron deficient, it is electron rich. But in haloarenes, when if chlorines leaving group leave, then when OH minus, that is nucleophile, which is electron rich, when attacked to this site, the electron present in the ring repulsed to the nucleophile. It means the attacking of nucleophile is not possible. So we say that it is not reactive, it is less reactive towards SN1 reaction, SN reaction. Okay, student? Dear student, you know that due to some reason, haloarenes are less reactive towards the SN reaction. Dear student, but when we want to do SN reaction for haloarenes, dear student, then a special condition, that is drastic conditions, are required. Without drastic condition, it is not possible to react haloarenes in the path of SN reaction. Okay. Dear student, here we discuss some nucleophilic substitution reaction in haloarenes in drastic condition. Dear student, first is the replacement by hydroxy group and formation of phenol. Dear student, when haloarenes react with the sodium hydroxide in drastic condition means at the 623 Kelvin temperature, higher temperature, 300 atm pressure, higher pressure. This is a drastic condition for the reaction. Without this drastic condition, high temperature, high pressure, it is not possible to react haloarenes toward SN reaction. Okay. So if we apply drastic condition, 623 Kelvin temperature and 300 atm pressure, dear students, the OH of sodium hydroxide will replace the chlorine present here and convert into phenols. Okay, like here, when sodium hydroxide react with the haloarenes, firstly it formed an intermediate, that is sodium phenoxide. After reaction, when we treated it with the sodium hydrochloric acid for the maintenance of the pH, dear student, when we use NaOH, then pH of the solutions became high. So maintenance of the HCl, the pH maintenance by using HCl. When we use HCl, then the sodium of the phenoxide react with the Cl and form NaCl, and the hydrogen of the acid join to this oxygen of phenoxide ions and convert into phenols. Just to always remember, when we use haloarenes, then haloarenes react with sodium hydroxide in drastic condition. Hydroxide of the sodium hydroxide replace the chlorine, replace the hydrogen, and convert into the phenols. Okay, dear student, always remember the presence of an electron withdrawing group. Electron withdrawing group means electron pooling group. Electron withdrawing group means electron pooling group. Dear student, NO2 is an electron withdrawing group, means electron pooling group. Cn is electron withdrawing group, that is electron pooling group. C dual OH is also electron withdrawing group. Dear student, if in a haloarenes electron withdrawing group as like NO2, HCl and C double OH at ortho position or para position. Dear student, this electron withdrawing group increase the reactivity of haloarenes. Dear student, now we have a method to increase the reactivity of haloarenes towards SN reaction. By which method? Dear student, you know that you read here, we increase the reactivity of haloarenes towards the SN reaction by adding electron withdrawing group, electron pooling group at the ortho or para position. Okay, like here, dear student, in this question you observe here, this is the main position and adjacent position of this ortho, meta and para. You observe here a nitro group, that is NO2 group present at the para position. Dear student, you know that without presence of nitro group, means withdrawing group, if you react it with the sodium hydroxide, it react at the 623 Kelvin temperature, but in presence of electron withdrawing group at the para position, this reaction occurs only at the 443 Kelvin temperature. Okay. But when we join two nitro groups, one is ortho and one is at the para, then the reactivity enhance and this reaction occurs only at 368 Kelvin temperature. Okay student? Dear student, when we use 3 nitro groups at 2 at the ortho position and 1 at para position. Dear student, for this reaction the reactivity increase, and in this reaction do not require more and much heat, only warms it with water, it converts into phenols. Dear student, I think you understand how to enhance the reactivity of haloarenes toward the SN reaction. Dear student, it is just adding electron withdrawing group as like NO2, Cn and COOH at the ortho and para position. As the number of electron withdrawing group increase at the ortho and para position, you know that the reactivity increases and then increases. Okay. Dear student, in next lecture we discussed about haloarenes and also the for haloarenes acid reaction and electrophilic substitution reaction also. After that the chapter is ended. Dear student, it is request, please read this topic in NCERT book and solve the questions related to this topic. Okay, and write all about in your notebook. Thank you very much.